At this point, hopefully you've learned enough so that if someone were to draw a circle and give you the center and radius information, you can immediately write out the equation of a circle. So, for example, here's a circle, and the radius, the center is down here, and here's the circle. Now I've got to put some numbers on this. Pretend that this is a well-drawn circle, please. And suppose the center is at 4, -3, and the radius is 6 units. Okay, radius is 6, center at 4, -3. Well, then the equation of the circle would be x minus 4, quantity squared, plus y plus 3, quantity squared, equals to 6 squared. 6 squared is 36. So that would describe the equation of this circle. And it uses that standard form we developed from the Pythagorean theorem and distance in the plane. All that ties together here in this. So hopefully you're good at that now. Now I'm going to work a few problems where circles are described in different ways, and then we use that information in order to find the equation of a circle. So it's not too much different from what you see here. We just may have to massage the information a bit. So I'll come up with a problem. Here's the problem. The point -5, 8 lies on the circle with center at 2, -1. So I'm going to draw a little sketch of this, get kind of an idea of what's going on. And I think, when you draw a sketch, it's usually a pretty good idea. All right, so 2, -1 is down about here. And the point is at -5, 8, which is, we'll say, up here. All right, so that's, just a rough sketch. So I have, this one is the center, so the circle radiates out this way. All right, you get the idea, hopefully. Now then, well, with the center, I can immediately write down most of the equation. Because the center, the equation of the circle is going to have this form. It's going to be x minus 2 squared plus y plus 1 squared equals 2 radius squared. So the center is 2, -1. Remember, it's x minus h, x minus 2, and then y minus k, y minus -1. And the minus -1 is what gives us the positive 1. Equals radius squared. Now, how do I find the radius? Well, I could use distance, form a right triangle, calculate distance, and take the square of the distance. Actually, that's sort of taken care of here, believe it or not. Because if I plug in this coordinate point into my equation, I literally am working the Pythagorean theorem in disguise. But this coordinate point, since it lies on the edge of the circle, has to satisfy the equation of the circle. So when you plug the numbers in, everything should equal out. Well, when I do that, I get -7 quantity squared plus 9 squared equals the radius squared. This is going to be 49 plus 81. And so that would be, 120, 130 equals to r squared. And so the equation of the circle is this, with r squared being 130. So let me write that out, the answer out. Don't forget to write the answer. A lot of students will do this work and stop, and they somehow they forgot to write the answer. So all right, the equation is going to be x minus 2 squared plus y plus 1 squared equals to 130. So remember, r was already squared here, so I don't need to fiddle with it in any way. We're done. That's what it is. Now it's, how do you check these things? Well, this does have a center at +2, -1. So that piece of information checks out. And provided that this number, when you on this point, when you plug this point in, you get 130, then you're okay. You've got the right answer. So the problem is finished.